Hello everybody, and welcome back to pre-calculus class. Today we plan on talking about the derivative. If you remember, the derivative is, let me move this over, the derivative is a thing that you're going to spend 2/3 of your time in a Calc 1 class finding. And what it really ends up being is it ends up being the slope formula is what we're looking for. So I thought we'd warm up by doing a problem from yesterday. As you can see with this technology, some things got cut off. That's what the problem is supposed to say. So yesterday we talked about limits, and specifically limits as you head towards a finite number. In this case, I want to know what's the limit as x approaches -2. What I'd like to do is just plug in -2. If you plug -2 into the denominator, you would get -2 squared is 4. 5 times -2 is -10, plus 6, you can see the denominator ends up giving you 0. Well, that doesn't help us, all right? So we can't have 0 on the bottom. So what that tells me is I can't just substitute in the variable in order for the number in order to see what it's equal to. So go to the second thing, all right? And this is set up for the second one. All right, the second method for evaluating a limit says to factor, reduce, then substitute. We have our limit as x approaches -2, and then your job would be to factor the top. The top looks to me would factor into x minus 7 and x plus 2. And the bottom would factor into x plus 3 times x plus 2. So there's the factoring part. The reducing, we can go ahead and cancel out the x plus 2's. And in substitute, we'll take our -2, plug it in for x in the top and bottom. In the numerator, that gives me -9. In the denominator, that gives me 1. So that tells me my slope is, or my limit is equal to -9. All right, now, if I type this into the calculator, y equals that fraction, I can trace right around -2, and I would see that both from the left-hand side and right-hand side, we're headed towards a y value of -9. Now remember, a limit is a target. So all this means is this fraction is getting closer and closer to the number -9 as x gets closer and closer to 2. Not that it's actually equal to -9, but it has a target of it. Okay, so the idea behind the derivative here is if I were to, well, how about this? When you have a line, all right, we know the slope is the same everywhere, and that's what the derivative is telling me. The derivative is telling me what is the slope, all right? What is the m value? It doesn't matter what point I'd happen to pick on the line here. The slope's going to be the same everywhere. I don't need calculus for that, all right? Instead, in calculus, when we're given curves of different sorts, you're now looking for the slope along this curve. And depending on what point you're at, that slope is going to keep changing on you. Sometimes they're going to be positive, sometimes they're going to be negative, uphill, downhill, positives, negatives, positives. Sometimes you're going to have that slope of 0. So what we have here is we have an equation that would tell us the slope, and that equation is what's called the derivative. Now, in order to find the slope, we want to use this old formula. Let's do y2. All right, so in order to find the slope, we're going to need to find 2 points that are on that curve and then use a slope formula in between them. All right, let's see how that works. All right, I guess here, let me give you the definition first. The derivative is a slope formula to an equation or the slope at a specific point. I'm going to go ahead and give you the notation also. So for functions, we either write f of x or we write y. They're the same thing. For the derivative, we write it as f prime x or y prime. Now, Sir Isaac Newton used the prime, all right, so it's not a 1, it's a prime. Leibniz used dy over dx. And if you notice, dy over dx is basically change in y over change of x, which is our definition of the slope. All right, there is a slight difference between these two, all right, but they are very close, all right. The dy over dx, the change in y over the change of x actually refers to a slope. It could be over a big distance between the 2 points, where the dy over dx represents the slope in between 2 points that are right next to one another. Okay, so let's take this example here. All right, it says find the derivative, which means find the slope formula of the function of y equals x squared. So y equals x squared is a graph that looks like this. So if I'm looking for my derivative, if I'm looking for my slope, I need 2 points that are going to be very close to one another. The first point I'm going to pick, I'm just going to pick one here in the first quadrant. And that's going to be forward x units, and it's going to be up y units. But instead of y, let's use the definition here. If y is equal to x squared, this would be x squared. So the point that I have here would be x and x squared. And that way I can write a point using one variable rather than 2 variables. Now the second point I pick has got to be close to that, but it can't be at the exact same point. All right. If I take the same point, x squared, and I plug those into my slope formula, m equals y2 minus y1 over x2 minus x1. If I take y minus y and they're both the same, I get 0 on the top and x minus x in the bottom and give me 0. I'm going to get 0 over 0. That doesn't help me. So instead what I do is I move a little bit away and I get a second point. Now how far away is that? So originally we moved forward x units. I want to go just a little bit forward from there, and we call it h units more. So that's new point here is the point xh, at least for the x coordinate. If you take that xh and you plug it up into your equation, the y value would be x plus h squared. So the 2 points that I'm going to use would be x and x squared, and an x plus h and x plus h squared. Now this y value in here is going to keep changing, all right? Just like this one keeps changing. It all depends on what's the equation that you're given. These values will stay the same, all right? So one of your points will always be x, and then whatever the y is, and one of the x values will always be x plus h. All right, that point that's a little distance ahead of that. Now, when I plug these into the slope formula, let's keep in mind that I want these points to be very close to one another. So right now, I get a line that cuts through them that looks like that. Now, that's a little tough to see. That's not the same as what's at the slope at this point that we're looking for, all right? But it is close to it. I'll come back to this slide here in a moment. My 2 points, x squared, and x plus h squared. So my slope formula says I need to take y minus y, x plus h squared, and we always start with that one, minus x squared, over x plus h, the second x, minus the first x. Now, as you can see, when you simplify this, you're still going to be left with h's in the equation here. So let's think about what would happen. If I subtract these, I am looking, let me find a different color here. I'm looking for the slope that's right in here. Unfortunately, right now, I have the slope that's right in here. So what I want to do is I want to make this h as small as possible. As h gets smaller, this point and this point, let's see, that's going to be tough to see. So let's do this. All right, there's that. This point, there's my forward x, and this point, there's my forward if I went x plus h. All right, as I bring that point closer to the original point, this h is going to be very small. What I want is the h to be 0, but I can't have it being 0, because if I plug 0 up in this equation here, I'm going to get 0 over 0. All right, that's indeterminate. Now, what we're really talking about here is we really have a limit. All right, I want to know what is this fraction equal to as h heads to 0. If h is equal to 0, or as h gets closer and closer to 0, what will that function be equal to? All right, so this is a limit. I'm asking what's the limit as h approaches 0 to the function or fraction x plus h squared minus x squared over x plus h minus x. Right? That's what it's your job to evaluate. Instead of calling this m, we'll call it y prime, or dy over dx. Okay, I need some room, so I'm going to rewrite this. All right, I just asked, what's y prime? I know it's the limit as x approaches, let's do this the right way, as h approaches 0 of x plus h squared minus x squared over x plus h minus x. Okay, let's distribute everything up above. So if you took x plus h and squared it, that would give you x squared plus 2xh plus h squared, and then we have a minus x squared. In the denominator, you've got x plus h minus x, and when you simplify that, would give you h. Well, that should make sense, all right, because in the bottom, we're looking for what's the change in the x's. It should be h, because we made that distance, and the top is what we don't know, all right? That's where we distributed everything. This would simplify a little to give me the limit as h approaches 0 of, let's see, up in the numerator, I get 2xh plus h squared, because my x squared minus x squared is 0, and in the bottom I get h. So now the question is, can you plug in h equals 0? Well, no, because I get 0 in the denominator. But now this limit would fit into what we were looking at yesterday. What can I do? Well, I could factor the top and simplify. I can split this into two fractions and simplify. In fact, let's do that. The limit as h approaches 0 of 2xh over h would be 2x, and h squared over h would give me h. And now you can plug in h equals 0. And what you're left with is y prime equals 2x. That is your slope formula. That is the equation that would tell you the slope anywhere along the curve y equals x squared. So we have two equations here that we're working with. All right. We have y equals x squared. That's the one that's given. All right. That gives you position. That gives you location. That gives you the y value. And you have this new one called the derivative. This tells you how steep you're going to be at any point. You get these different points. -3, 9. When you plug -3 into the equation, you get back a y equals 9 into the original equation. When you plug -3 into the slope formula, you get -6. That's how steep that curve is at that point. If you think about drawing a tangent line there, if I can actually draw a tangent line, maybe that's a little better. That should have a steepness of -6. So what we do is we use that derivative to answer questions. So for example, it says on the graph of y equals x squared, what is the slope at, and then you can be given some points. So in order to find the slope, you need the slope formula. For y equals x squared, the slope formula we found out was 2x. All right, all you have to do is double the x value and you'll know the slope. So how about the point 416? As it turns out, I don't need the 16 to help answer this. I only need the 4. All right, if you plug 4 in here, you would find out that the y prime of 4, that means the slope, because it's y prime of 4, is equal to 8. Y of 4 equals 16. All right, but the equation y tells me my height or my y value. Y prime tells me the slope, and I know I've got a steepness of 8. Let me get rid of that. Let me cut back. Whoops, that's a y there, wasn't it? Y prime. Okay, how about at the point -3, 9? Y prime of -3 is equal to what? I go to my slope formula, I plug in my -3, and I get -6. It has to have a steepness of -6. What about if x equals 7? Well, these y's up here were extra information. I didn't need to know what they were. All right, when x equals 7, I need to know y prime of 7. I plug 7 in. If I double 7, I should have a steepness of 14. Right? And it should make sense because, again, along that parabola, as your x's get larger, you can see your steepness of those slopes, right? Those points, the slopes at those points are going to get steeper. And if x is getting smaller, like back here at -3, all right, you also have some steeper slopes, but in a negative direction. All right, now we want to make sure that we can find the derivative of any type of function. So let's think about if I have some curve. All right, so might be an upside down quartic, might be something else that we haven't even talked about yet. If I want to find the derivative, the slope formula, at any point along here, I'm going to pick 2 points. 1 point and then a second point that's going to be close. All right, here's my x, and then I'm moving h units forward, so x plus h represents the second point. So for my first point up here, it's always going to have a coordinate of x in whatever this f of x is. Right? You're going to be given some equation like x squared, or a tangent of x, or log x. Your second point is always going to be x plus h, and then your job will be to take that x plus h and plug it up into your function. And you've got f of x plus h. And then what we want to do with these 2 points is we want to plug them in the slope formula. And when we plug them in the slope formula, let's remind ourselves, this little h value that we have here, we want it to be as small as possible because we want those points right next to one another. We want h to be equal to 0, but remember, you can't plug in a 0 here or the slope formula won't work. So we'll just leave it at h and we'll ask ourselves what's the limit as x approaches h. So if I take those 2 points, I would have the limit as h. I better do it the right way. As h approaches 0 of f of x plus h minus f of x over, now on the bottom you're always going to have an x plus h minus x, and this x and this x will cancel and you're always going to be left with h. That's what we call the definition of a derivative. There are times you're going to have to use this definition. There are other times where you're going to know some shortcuts, and you're going to use those shortcuts then. For today, that's the formula that you want to use. Right? You don't want to have to draw pictures, right? And especially have to draw them on a computer trying to use these programs correctly. All right? So let's go through this. Let's come back here. What do I need? I need to know the original function, and I need to know what would the function be equal to if I plugged in x plus h anywhere there was an x. So here's my original function. I now need to know, what do you get if you plug in x plus h? So let's see, if you plug it in here, you'd have x plus h squared. If you plug it in here, you'd have minus 5 times x plus h. And if you plug it in here, well, there's nowhere to plug it in, you're going to be left with 11. These are the two functions that you need. F of x plus h minus f of x over h. All right, so let's find f prime. F prime of x prime. Remember, it's not a 1 up there. All right, I don't particularly like that. Prime equals the limit as h approaches 0. That will always be the same. All right, h approaches 0 just means you want 2 points that are right next to one another, of this function, which is defined by x plus h squared minus 5 times x plus h plus 11, take away f of x. Take away, and in parentheses I have to plug the whole f of x in. X squared minus 5x plus 11. And that's all over h. And so your job then is to evaluate the limit. You have all those methods to evaluate the limit from yesterday. All right? You're never going to be able to plug in h equals 0 because the bottom would be equal to 0. All right? So you're going to have to use one of the other methods. Now, in most of these cases, since you're going to be working with mainly polynomials, all right, your job will be to distribute everything that you can in the top and add like terms. So why don't we do that? F prime of x equals the limit as h approaches 0. There's going to be a lot of terms here. So x plus h squared, we've already said once, is x squared plus 2xh plus h squared. Distribute the 5, negative 5x minus 5h plus 11. And then over here, let's make sure we distribute the negative that's in front. So negative x squared plus 5x minus 11 all over h. Now at this point, what should happen is any term that doesn't have an h in it should cancel out. So for example, you've got an x squared here, you've got a minus x squared here. they will subtract to 0. You have a minus 5x, you've got a plus 5x. They will cancel to 0. You got a plus 11, you got a minus 11. They will cancel to 0. Every term that was in your f of x here will cancel to what's in the front. Okay, so what's still left over? I'm going to have to move on to the next page. All right, so f prime of x equals the limit as h approaches 0, and we keep writing that until we plug in h equals 0 of, I'm left with a 2xh and an h squared, 2xh plus h squared. I'm left with a minus 5h. And I've got an h in the bottom. All right, so a lot of terms did cancel out for us. Limit. Okay, now I still can't plug in my h equals 0 because it still makes the bottom equal to 0. But now I can take this fraction and I can do what one of the methods that we talked about yesterday. And in this case, we can factor, reduce, then substitute. F prime of x equals the limit as h approaches 0 of, I can factor an h out of every term. That leaves me a 2x plus h minus 5 over h. So there's my factoring. There's my canceling. And now I can plug in h equals 0. And what I'm left with is f prime of x is equal to 2x. When I plug in a 0 there, I get nothing, and minus 5. And that is my derivative. That is my slope formula. So we have two functions that you can use to do with problems in. All right, you've got f of x equals, that's not what I want. Let's do this a little cleaner. You've got f of x equals x squared minus 5x, and we had plus 11. This is a function that would tell you y values. And then you've got the second one, f prime of x equals 2x minus 5, which is your slope formula, which should tell you the slopes. All right, f of x, f prime. Two different things that we have there. And it looks like there are two primes there. There aren't. All right, there's only one, right? Because there is an equation that has two of them, right? And that'll be coming up in a couple of days. Okay, let's do the same here. Let's find the slope formula. So I have my y. Now we know y is the same thing as f of x. All right, we need f of x plus h. So anywhere you see an x, plug in x plus h. And that would give me the square root of 3 times x plus h. All right, anywhere there was an x, I plugged in x plus h. Okay, we'll go to our derivative formula, our slope formula. Y prime equals the limit as h approaches 0 of the second function minus the first function over h. Okay, evaluate the limit. I cannot plug 0 in there. And unlike the last couple, I can't factor this. So think about what is the method for evaluating a limit where you have radicals. And what we talked about to do is to multiply by the conjugate. So in this one, I'll multiply by the conjugate, which should be the square root of 3 times x plus h plus square root of 3x. And I'd have to multiply the bottom by square root of 3 times x plus h plus square root of 3x. All right, what's that leave me with? The limit as h approaches 0. Now, if you remember from what I said yesterday, wherever you got the conjugate from, which in this case is the top of the fraction, you want to multiply those together. Wherever you did not get the conjugate from, you don't want to multiply. So on the top of the fraction, see if I FOIL this, square root of 3 plus 3 times x plus h times itself would be 3 times x plus h. We know the inside and outside terms cancel with one another. And my last terms would be a minus square root of 3x and a positive square root of 3x being multiplied, which would give you a negative 3x. In my denominator where I did not get the conjugate, I want to leave that as h times the conjugate. Okay. Can you plug in h equals 0 now? No, because you're going to have 0 times the whole quantity, which would be 0. But now we can start doing some simplifying. In the top of the fraction, you should distribute the 3 through the parentheses and combine like terms. All right, the limit as h approaches 0 of 3x plus 3 h minus 3h. And in the bottom, I got to remember what I had there. I had h times my conjugate, square root of 3 times x plus h plus square root of 3x. Okay, so let's simplify our top, the limit. You know, I think I'll do that in a different color. The limit as h approaches 0 of, in the top I get a 3x or 3h. In the bottom I've got h times my conjugate. There's a lot of math here. It's not hard math, but there is a lot of math involved. Now, I still can't plug in h equals 0, but hopefully you'll notice that this h that's in the top that's being multiplied can cancel out the h that's being multiplied in the bottom. And now you can plug in h equals 0. And that will give you a 3 over, notice I don't write the limit anymore because I'm now evaluating. If you plug a 0 into the first quantity, you'd get the square root of 3x plus, and there's no h in the second, square root of 3x, which means my y prime is 3 over, you have 1 square root of 3x plus 1 square root of 3x, which would be 2 radical 3x's. And that there is my slope formula. That would tell me the slope anywhere along that curve. Okay, so you got several different ways to evaluate limits. All right, and in this one we had to use the conjugate. In most of the ones you can use you can use factoring, eliminate, and then substitute. All right, none of these will be as h approaches infinity. All right, there are special cases when we do use that, but definitely not in the derivative formula. So today we talked about the derivative. The derivative is just a slope formula. All right, it's a slope formula to a curve. You're going to start working with several equations. One of the equations will be f of x. We know this is the same thing as the y's. It tells you the y's. The second one is the derivative. That's your f prime of x. This is going to tell you slope. All right, how are you going to find that f prime? All right, the notation, you might have an f prime, you might have dy over dx. You might just have y prime. All right, so if you're using the prime, that's Sir Isaac Newton. If you're using, all right, the dy over dx, that's Gottfried Leibniz. The formula to find this slope formula is the limit as h approaches 0 of f of x plus h minus f of x over h. You would substitute in the original function. That's right here. You would substitute in the function after you've plugged in x plus h, and then you start doing the math until at some point you're finally going to be able to plug in h equals 0. All right, for your homework tonight, right, you should download or you should take a look at the worksheet that it's called derivatives. Right, the link is right next to the link that you had for this lesson. And we will be talking to you very soon. Again, this will probably take you a couple of days to do. Good luck.